This is Mrs. O'Neill for AP Chemistry, Chapter 2, Section 8, Naming Inorganic Compounds. Another review from Chem 1 that some of you might have struggled with, so this might be another video you might want to keep on hand to review throughout the course. The objective: write the systematic way in which substances are named. This is called nomenclature, and how this nomenclature is applied to inorganic compounds. So again, I want to remind you, you may want to pause the video, fill in the blanks in your packet, and then play to hear my words. So we want to remind you that a ionic compound will start with a metal, and we're going to name that metal, and sometimes we need Roman numerals. For the ending, for the one element, we're going to change that non-metal to IDE. And if it has two or more elements in the second part of the compound, we just name that polyatomic ion. And this is why you just learned that in the previous section. So when we name cations, remember these are the metals, these are going to be all of your elements that become a positive ion. We're just going to name the name. But if we look down here, I want to remind you that there are going to be multiple elements that you actually need to use the Roman numerals. So for instance, iron. Iron can either have a +2 charge or a +3 charge, and that's where that Roman numeral comes in. But potassium, no matter what, aluminum, no matter what, will only be those specific charges. So potassium can only ever be +1, so we don't have to give it the Roman numeral. Aluminum can only ever be +3, so we do not have to use the Roman numeral. Same thing with barium. So if you notice here, barium can only ever be +2, so you do not need the Roman numeral. If you put the Roman numeral when it does not belong, it will be marked wrong. If you don't use the Roman numeral when you're supposed to, it will also be marked wrong. So you really need to keep an eye on what elements need those Roman numerals when we name them. So the elemental anions, so these are your nonmetals, and your nonmetals are going to be the second part of the compound. The one thing you want to take notice is what happened to the ending. Every single time we change the ending to IDE. And if you're not sure where to break it off, like chlorine to chloride, that one you've heard of a lot, so that one you're used to. But something like let's say nitride, right? You might not have heard of nitride very often, right? So nitrate to nitride, that might be a little confusing. So at this point, you will get to know how to break off, what part to break off of the ending of the original element name and where to put the IDE. So simple ionic compounds are composed of just the cation and the anion, in other words, the metal and the non-metal. So you're just going to name the cation name, again, the metal part, and use Roman numerals if necessary, and then you're going to change the anion, the non-metal, to IDE. And we want to remember that those charges must be balanced. So this is where those crisscrossing comes in. So K is +1, Cl is -1, so they cancel each other out. Ca is +2, S is -2, so they cancel each other out. And you always want to remember that you do not write the charges in your compounds. You never see charges in compounds. So if you do need to write the charges of a compound, see if you need to crisscross them, then rewrite the compound without the charges, okay? We also want to remember, check your subscript. So this is wrong because Ag is +1, Br is -1, so they both have a 1 charge number, so you would not see that 2 there. And this is really interesting as well. Let's go down to this bottom line. Copper is +2, SO4 sulfate is -2, so charges cancel out. Al, aluminum, is +3, SO4 is -2, so notice the 2 comes down here and the 3 comes here because we crisscross them. Here, we have barium +2 and hydroxide -1. Now, for the most part, yes, you do have to bring down the 2, but because hydroxide is a polyatomic ion, even though it doesn't have any numbers with it, you still need parentheses. So we want to make sure that we understand these simple rules. So naming acids, remember I told you that the acid is going to come from the anion. So an acid always starts with hydrogen. There are going to be some exceptions to the rule you're going to see throughout the course where the hydrogen is actually at the end of the acid formula. And again, that's because of the way it's structured. The way if you were to draw it out using like a ball and stick model, you would actually have the hydrogen on the other end. And that's why that Some of them are odd. And again, so back to the anion is going to tell us how to name the actual acid. So if we look at this, here's our acid, HCl. One of the things I always remind you is for the acid, when we want to name it, break it apart. Take that H away, that's the acid part, and what's left over? The anion. So the acid name is going to come from what the anion is. So let's look at these of the rules. So we'll go down to the bottom here because that's what this is up here. So the Cl-1, you would name that as chloride. So if the ending is chloride, IDE, you're going to name hydrochloric acid. Okay, so this is hydrochloric acid. The anion ends in ide, so we're going to do hydrochloric acid. If the ending ends in ate or ite, those are your polyatomic ions. You just need to remember that your ates polyatomic ions are going to change to ic acid, and your ites polyatomic ions are going to change to us acid. And here's a quick or cute way to remember it. Ates to ic because I ate something icky, and ite to us because Sprite is delicious. So somebody a couple years ago gave me that little mnemonic, so I figured I'd share that with you. That might be a way to remember. So for molecular compounds, they start with a nonmetal and they end with a nonmetal. And you need to use prefixes. If you need to look at those prefixes, look at page 65. I believe I have some on the next slide. We want to remember that the first part you always name it, but you do not need mono if there's only one of them. It goes by how many atoms there are. And of course the ending, one element, IDE, and you give it a prefix. So again, covalent compounds, I thought there was some here. 1 through 7, how many are they? So we're going to use the prefixes. So let's look at some examples here. There's 1 iodine, so it's iodine, no mono, because it's the first part. And then there's 5 fluorines, so penta, because that's 4, 5, pentafluoride. We always want to change that ending, because again, we're naming that anion at the end. For nitrogen, because there's 2 of them, that's where the di comes from, dinitrogen. Pentaoxide, because there's 5 oxygens. CO would be carbon monoxide. There's no mono in the first part, okay? So a covalent compound never starts with a mono. We want to remember that. And, ooh, look down here. They're trying to trick you here, but magnesium is a metal. So this is actually an ionic compound. So it would just be magnesium chloride. And this is where you need to make sure you're not getting confused with an ionic compound starting with a metal and a covalent compound starting with a nonmetal. So I would quiz yourself here as well. You have some practice problems, some going from names to formulas and some going from formulas to names. You also did some of this in your summer assignment. So I would just suggest, again, I'll click through. Here I'll kind of stop talking. And I expect some questions then during class. So here you're writing the formulas. Formulas again. And for thiosulfate, you might need to look at that polyatomic ion sheet I gave you for your summer assignment. That's a weird one, but I wanted to at least give you some weird ones because on the AP exam, they're not going to give you all the time stuff that you know, but they're going to give you something that you should be able to use. So if they would have given you something like ammonium thiosulfate and they would have given you the components, the Al+3 and the thiosulfate S2O3-2, you should be able to make a compound with it. So I'd like to sometimes give you these examples because on the AP exam you're going to learn certain information, but then they're gonna test you on things that maybe you've never seen before, but you have to relate it to something that you've seen. So this is a perfect example of that. This thiosulfate you're not going to see very often, but you're going to say, oh, sulfate reminds me of polyatomic ions. It's got to be some kind of polyatomic ion. So even if you were to put an X here and to say, hey, this is a polyatomic ion, it's an X, not sure what the charge is, but you kind of tell them that you know what it should be, you might get partial credit. So we're going to keep that in mind. Now we're going to go to naming, going the other way. And again, naming. And we move on to hydrates. Hydrate is a molecule that has water attached to it. So a salt or an ionic compound, and it has water molecules attached to it. So what we do is we name, and the formula needs to indicate how many of these water molecules are there. So how do we name a hydrate? We're going to just add the hydrate with the prefix, and that's going to tell us how much water molecules. And I believe I have an example on the next slide. And then the formula, you're going to see a dot. You're going to see the salt and then a dot with the number of water molecules. So here's an example. Calcium chloride dihydrate. So you should be able to know how to formulate calcium chloride. That's an ionic compound. And the di means that there are 2 water molecules. That's where the hydrate comes from. So calcium chloride would be the CaCl2. The dot meaning that it's a hydrate and it has 2 water molecules. That's where the di comes from. So now let's go the other way. Again, chromium is an ionic compound. Or I should say, I'm sorry, chromium is a metal, and with the NO3, it is an ionic compound, and here we have 6 waters. So you're going to name the ionic compound. 6 is hexa hydrate. So here we go, chromium 3 nitrate, that's the ionic compound, and we have hexa because of the 6, hydrate because it's the water with a hydrate molecule. And that's it. I expect some questions in class. And I also do have more practice worksheets if you need them. Okay? Come see me anytime. Thanks. Bye-bye.